This chapter will introduce you to the various levels of software used in your Apple III. You won't have to work with the information presented in this chapter every day, but as you progress with your new computer experience and as you read new computer magazines and news articles, you'll find that knowing about the levels of software will help you understand your own system better. Will also help you to understand the sophisticated operating system, known as SOS. That makes your Apple III one of the most powerful personal computers ever designed. You've heard the word program used extensively when talking about computers. A program is a pre-written set of instructions that tells your computer to perform a specific task. That task may be as simple as telling the disk drive to start running or as complex as allowing you to do a 5-year financial projection for your company. A program is a set of instructions written in a language that your computer understands. Programs are generally referred to as software, and they can be written in various levels of language depending on how and where they're used within your computer. Generally, software can be divided into two categories: application software and operating system software. Application software means applying a program to do a specific function or task or to solve a specific problem. Application software could be used for inventory control or financial projections for a company. Most of the pre-programmed commercially available software packages, as well as programs you may generate to do a particular task you need done, fall into the category of application software. We'll deal with application software in further detail in Chapter 8. Operating system software is a more internal kind of software. An operating system is essentially a way for your computer to know how to get information from the keyboard, send it to the screen, and to manage the various other devices connected to your Apple III. The operating system you are using is called SOS, pronounced SOS, and it stands for Sophisticated Operating System. Some other operating systems available on other computers are DOS, which stands for Disk Operating System, and CPM, which stands for Control Program for Microprocessors, and there are other systems. CPM is a very popular operating system that has many applications programs written for it. You can add the CPM operating system to your Apple III. If you do, you would then be able to run any programs written to run on that system, as well as programs written for your Apple III's SOS. Many people think of the operating system as a traffic cop, directing the flow of traffic from many different directions into many other directions. The operating system allows you to work with application software and frees you from worrying about the hardware. Your sophisticated operating system contains a group of smaller programs called device drivers. Each device connected to your Apple III has its own driver. Remember, your operating system, as it communicates with the various driver programs, manages the hardware of your Apple III. In Chapter 3, we found out that 3 groups of programs were essential for each boot disk to boot up correctly. In addition to the sophisticated operating system and the device driver file, an interpreter program forms the third element necessary for your Apple III's operation. An interpreter program deals directly with languages. Languages are the electronic words that programs use to run. There are various levels of language used in your computer. The highest level languages are those that you interact with directly. In fact, these languages use words or instructions that are very much like English commands. Words you give your computer, like run, load, save, and close, are examples of high-level language words. But at the other end of the scale, down at the electronic component level, your computer responds only to a series of on and off pulses to do its job. When you type in high-level language words, those words must be read by smaller programs called interpreters. These interpreters translate them into what's called machine and assembly language. It is in the machine and assembly language level where the work is done. Therefore, your Apple III boot disks need an interpreter program to translate the high-level language that you work with into the low-level language that the individual components work with. Apple Business Basic and Apple Pascal are 2 of the high-level languages available for your Apple III. BASIC stands for Beginner's All-Purpose Symbolic Instruction Code, while Pascal is named after a French inventor and philosopher of the 17th century, Blaise Pascal, who invented a mechanical calculator when he was 18. Other languages used in computers today include Fortran, which stands for Formula Translator, COBOL, which stands for Common Business Oriented Language, and Pilot, which stands for Programmed Inquiry, Learning, or Teaching. There are other languages also. These languages all serve different purposes and need interpreters to translate their commands into machine and assembly language. It might be helpful to think about the relationship between the operating system, device drivers, and the language systems this way. You and a friend are in a new country and your friend wants to get to a place 20 blocks away. You hail a cab. You are the application software. You have the necessary information how to get from one part of the city to another, calling a cab, but you can't speak the local language. The cab driver is the system software. You ask an interpreter to tell the cab driver where your friend wants to go, but you don't have to tell the driver how to get there. His knowledge of the city and his ability to drive the cab is the operating system. The language you speak to tell the interpreter where you want to go is the language software. The translation that the interpreter does is the interpreter program. Your cab driver, the operating system, tells the engine how fast to run by pressing on the accelerator, the device driver. The machine and assembly language tells the parts of the engine, the crankshaft and pistons, when to go up and down. The machine and assembly language is the lowest level of communication within your computer. However, it's at this level that all information and data is reduced to the very simple form of binary codes that enable your computer to function. At its simplest level, binary coding is a method of taking a number or letter and reducing it to a series of on and off electrical impulses that represent that letter or number. If you were to switch the light switch in your room on, then off, then on, then off again, you would have created a code that could be represented like this. In binary coding, you would have expressed the number 10. Since we can reduce any number into a code of pulses that consists of either an on or off, positive or negative state, we can use this ability to store these pulses in electronic circuits. There are tens of thousands of tiny storage chambers inside each integrated circuit chip where simple on or off electrical impulses are stored. We won't get into the mathematics involved in binary coding in this program because you really don't need to use machine or assembly language to use your Apple efficiently. However, you might want to know what the 128K or the 256K stands for when it's used to describe the amount of memory in your Apple III. Early computer programmers decided to assign a number to every letter in the alphabet as well as to certain symbols. And since binary coding reduces every number to a series of on and off pulses, these letters and symbols can now be expressed as a series of on and off pulses. Each individual pulse is called a bit. A positive or an on pulse is a bit, and a negative or an off pulse is a bit. A standard code was developed that could express all the letters of the alphabet and some signs and symbols by 8-bit arrangements of on and off pulses. We call these different 8-pulse combinations words. They are also called bytes. 8-bit arrangements are used because they can form 256 different combinations, which is more than enough for all the letters, numbers, and symbols. The 8-bit bytes are organized into kilobytes, 1,000 bytes. For technical reasons, however, 1,000 bytes is really 1,024 bytes. But the computer industry rounds off those extra bytes and refers to multiples of kilobytes in 1, 2, and 3-digit numbers. Therefore, if your Apple III has 256K of RAM, it can store 256,000 8-bit words in active memory, or 2,048,000 individual on or off pulses. Of course, by storing blocks of bytes on disk and only using active memory for what you are currently working on, you can gain a tremendous amount of usable memory. Each disk that you can use with your Apple can store about 140,000 bytes, or about 1,144,000 on and off pulses. That's roughly equal to 45 double-spaced typewritten pages. This chapter should have given you a better understanding of how the various levels of software interact inside of your Apple III. You won't have to be concerned with all of this information every day, but an understanding of it will help you understand how your computer relates to other systems you may read about. In the next chapter, we'll take a look at the many types of pre-written application software available to you for your computer.